Welcome students. This video is a part of digital learning program conducted by Frozen Public School. You can see here today we start our chapter number 4 of chemistry, that is chemical kinetics. What does it mean by these kinetic terms? Kinetic is generally is a physics term which means there is something is in motion. So today we discuss about the speed or velocity of reaction. That what speed that reaction moves on, that what time that is taken by this reaction to complete. Okay, this time may be a vary from microsecond to years, thousand years, decades may be there. For example, we have two ends. One is on one hand we have reactions like ionic reaction when we dissolve NaCl in water. So this dissolution of this salt or sodium chloride in water take very less seconds of time, very small amount of time. While in case of we take another example on other hand, that is rusting of iron, it took several years to carry out this rusting process. So by this chemical kinetic, we can classify reaction into three categories. One is a very slow reaction, moderate type of reaction, and very fast reaction. So all the ionic reactions are fast reaction. What kind of ionic reaction? It may be neutralization reaction, it may be dissolution reactions, it may be precipitation reaction. While all the molecular reactions are are moderate type of reactions. For example, Haber process, where nitrogen combines with the hydrogen to gives ammonia. That is moderate type of reaction. As similar, we have another third type of reaction, the very slow reaction, that is rusting of iron, which take several of years. Okay, so reactions can be classified on the basis of speed or their velocity into three category: very slow, very fast. These two type of reaction having no importance for us. Why? Very fast reactions occur within a microsecond, that we are unable to observe their speed or rate. While slow reaction are such slow that a scientist's life, that means 100 years, completely invest in to find a mechanism, find the rate of that particular corrosion reactions. That's why both kind of reactions are not suitable to study kinetism of these reactions. We can observe or study only moderate type of reactions and understand this kinetism or apply the concept of kinetism on this moderate type of reaction. So in this chapter we have only moderate type of reaction and understand how kinetism works. So the first definition comes into this chapter, that is the rate of reaction. Whenever this rate term is come, then that means something is, there is a time in the something is divided by the time, that is called rate. For example, rate of doing work is called power. So power has a time factor. For example, rate of change of velocity is called acceleration. That means there is also a time that is in the expression. So there is a rate, then there must be a time factor is there. As we know, the change in concentration of reactant or product per unit time. किसी भी टाइप की रिएक्शन हो, दो ही चीजें होती है, रिएक्टेंट और प्रोडक्ट. खेल ही रिएक्टेंट और प्रोडक्ट का है. सपोज रिएक्टेंट अगर प्रोडक्ट में कन्वर्ट हो रहा है माइक्रो सेकेंड्स में, तो ये काफी फास्ट रिएक्शन हुई. अगर कोई रिएक्शन में रिएक्टेंट्स कन्वर्ट हो रहा है प्रोडक्ट के अंदर, जिसमें काफी साल लग रहे हैं, तो इसे बोलेंगे स्लो रिएक्शन। और कुछ मिनटों में हो रही रिएक्शन, दैट इज कॉल्ड मॉडरेट टाइप ऑफ रिएक्शन। तो जो कुछ मिनटों में जो रिएक्शन हो रही है वही आपके लिए इस चैप्टर के लिए सुटेबल है, क्योंकि आप उन्हें स्टडी कर पाते हैं अच्छे तरीके से। वेरी स्लो रिएक्शंस भी आपके किसी काम की नहीं है और ज्यादा फास्ट रिएक्शन भी आपके किसी काम की नहीं है। तो पूरे चैप्टर के दौरान आप वही रिएक्शंस पढ़ेंगे जो मॉडरेट टाइप की रिएक्शंस। फिर यहाँ एक चीज आ जाती है, दैट इज रेट। रेट का मतलब है समथिंग दैट इज डिवाइडेड बाय टाइम। रेट की बात कर रहे हैं, so the it is a change in concentration of reactant or product। तो टाइम के साथ किसी भी रिएक्शन में क्या होता है, रिएक्टेंट की कंसंट्रेशन जो है वो चेंज होगी और प्रोडक्ट की भी कंसंट्रेशन चेंज होगी। अरे रिएक्टेंट कंज्यूम होंगे तभी तो प्रोडक्ट बनेगा। So we conclude from this concept that reactants are continuously going on decreasing. Their amount is going on decreasing, while the amount or concentration of product will gradually increases with time during any kind of reaction. हाँ, रेट कम और ज्यादा हो सकती है। So we find a basic expression for this rate. So you can see here the formula: change in concentration of reactant or product divided by time. अभी थोड़ी देर पहले जो मैंने बात की, रिएक्टेंट की कंसंट्रेशन टाइम के साथ क्या होती है, डिक्रीज। प्रोडक्ट की कंसंट्रेशन इंक्रीज होती है। यू कैन सी बाय दिस कर्व, these are the important facts that we obtain from this discussion. There is a concentration on y-axis, there is a time in x-axis, you can see here. So this is a graphical representation of a reaction, and this expression is valid for all kind of reaction. First point is reactants are disintegrate during reaction. That means they are consumed during the reaction while products are going on form. So how we calculate this rate? Suppose we have to find the rate at a particular point that's shown on your skin in orange color. It's a particular moment. So we have to, yes, we can find this del T by using this graph. Del P is a change in concentration of product. The basic motto of this graph is to define or to obtain expression for a rate. As we know, the rate is equal to change in product concentration upon time. While in case of uh, reactant, suppose we have to write the rate, then we have to write negative del R upon del T. There is a question. Why we put this negative sign here? Because the concentration of a reactant is going on decreasing. अगर ये डिक्रीज हो रही है तो रेट तो कभी डिक्रीज नेगेटिव वैल्यू नहीं होती रेट की। रेट नेवर अंडरगो, रेट नेवर रिप्रेजेंट एनी काइंड ऑफ नेगेटिव sign. Rate never be negative. So to make it positive, we already put a negative sign here. And because of the concentration of reactants gradually decreases, so we put another negative, and this negative becomes positive. That's why we put this negative sign here. Come to the next. So now we discuss the unit of rate of reaction by using these basic formulas. If we see there is a change in concentration, there is again a change in concentration. So the unit of concentration is mole per liter and the time is second. So the unit for the rate of reaction is mole per liter per second. Now we discuss the important aspects of rate of reaction in terms of stoichiometrics. What is stoichiometry? Suppose we have a Haber process here. This is called Haber process. I always give this example because I like it. Very simple example. This is a stoichiometry. So what we see, stoichiometry of nitrogen is 1, stoichiometry of hydrogen is 3, stoichiometry of ammonia is 2. How we convert this stoichiometry in terms of rate of reaction? Suppose we have to draw the expression for the rate of reaction. So we must know about the reactant and product. So whatever is put on the left hand side are called reactant, and whatever is written on the product side, not the product side, right hand side is called product. So what is the basic representation of this rate of reaction? We put a negative sign here. This negative sign we put because we know the reactants. Reactant always carry this negative sign because during rate of reaction, during rate, during moment of this reaction, there is a decrease in concentration of reactant. That's why we put a negative sign here. While in case of product, we put a positive sign here. And stoichiometry goes down the every expression. You can see here there is a 1 stoichiometry that is minus 1 by 1. There is a 3 that is minus 1 by 3. So this is a basic concept. Suppose rate of reaction is already given, then it represent the rate of disappearance of nitrogen. Okay, and this represent the rate of disappearance of hydrogen. We talk about numericals which are based on this concept in our next lecture. Today you have to learn how we write this expression only. Okay, so what we conclude that at the beginning of the reactant expression we have to put a negative sign, and at the beginning of product expression we have to put a positive sign, and write the stoichiometry upon site. That is the basic theme. So what are the types of the reactions? So we have two types of reaction. One is instantaneous rate of reaction, another is average type of rate of reaction. Suppose we have to find rate एट अ पर्टिकुलर मोमेंट. सपोज मैंने बोला 5 सेकंड पर रेट की थी, कोई रिएक्शन है 0 सेकंड से चली 30 मिनट पर जाके खत्म हो गई. किसी ने बोला मुझे 3 मिनट और 5 सेकंड पर रेट क्या है वो बताओ, तो वो रेट कहलाएगी इंस्टेंटेनियस. अगर किसी ने बोला कि 3 से 4 मिनट के बीच में क्या रेट रही, दैट इज कॉल्ड एवरेज रेट ऑफ रिएक्शन. तो आपको समझ में आया होगा कि एक पर्टिकुलर मोमेंट यानी कि पर्टिकुलर सेकंड पर अगर कोई रेट पूछ रहा है दैट इज कॉल्ड इंस्टेंटेनियस. चेंज तो होगा क्योंकि सेकंड्स के अंदर भी माइक्रो सेकंड्स है, तो माइक्रो सेकंड्स में रिएक्टेंट की कंसंट्रेशन घटी तो होगी लेकिन कम घटी होगी. ऐसे ही अगर मैं एवरेज की बात कर रहा हूँ कि 3 से 4 मिनट के बीच में कितना डिक्रीज हुआ रिएक्टेंट, घटा तो होगा लेकिन ज्यादा घटा होगा एज कंपेयर टू इंस्टेंटेनियस. सो इन केस ऑफ इंस्टेंटेनियस रेट ऑफ रिएक्शन, जब आप इंस्टेंटेनियस रेट ऑफ रिएक्शन का एक्सप्रेशन दिख रहे हैं तो यहाँ जो चेंज आया है रिएक्टेंट और प्रोडक्ट की कंसंट्रेशन में वो बहुत माइन्यूट है. दैट इज रिप्रेजेंट इन फॉर्म ऑफ डिफरेंशिएशन, दैट मींस स्मॉल d. While in case of average rate of reaction, there is a large change in reactant to product concentration, so we have to use del sign here. So you can see the expression, then जो भी मैंने समझाया वो समझ में आ जाएगा. थोड़ा सा उल्टा हो गया है, थोड़ा सा करेक्ट कर देता हूँ. थोड़ा सा चेंजेस है, I will correct it. Yes, you can see here. Yes, in case of instantaneous, there is a small change. That's why we put a D sign here. And there is a large change in case of average. So we have to put a del sign here. Mathematically, there is no difference. There is no effect on numerical answer. Come to the next. There is a question which also arises in our mind, that is there is a different unit for the instantaneous or average type of reaction? No, there is the same unit. They both of them are having same unit of rate, that is mole per liter per second. So the definition of instantaneous rate of reaction, it is a rate of reaction at particular moment or instant. Moment means particular क्षण. हिंदी में बोलते हैं क्षण. Next is average rate of reaction. It is a rate of reaction in between two different time intervals. That I already explained it, that in case of average rate, we talk about large change that is take place in concentration of reactant and product. While in case of instantaneous, there is a very small change that occurs. So this is all about today's lecture. This is the only introductory part. I tell you that you can find at your home examples of this slow type of reaction, average type of reaction, moderate type of reactions, or the very fast reactions. But the important question that I thought, the first question is write unit of rate of reaction, that is mole per liter per second. Second question is define a rate of reaction. As you know, what you write is a question number second. Yes, the change in concentration of reactant or product per unit time. Question number third, at the rate of reaction, following reaction in terms of stoichiometric terms. So you can see here, A is the stoichiometry of A, B is the stoichiometry of B, small c is the stoichiometry of capital C. So we put a negative sign here, you can see here. This negative sign indicates that these are the reactants. And in case of product, that is C and D, we put a positive charge. And this del sign represent here that we take average rate, not instantaneous. In case of average, we have to put a del sign here. Okay, so this is all about the expression. You can also form this stoichiometric expression for the other kind of reaction. Question number 4, during reaction concentration of reactant is gradually decreases. As you know, जब reactants consume होंगे तभी product बनेगा. तो उसका उल्टा product हमेशा जो है time के साथ बनता है. During reaction concentration of product is gradually increases. So this is all about today lecture. In our next lecture, we discuss about the rate law, molecularity and order of reaction, and different kind of orders. That means you have in your syllabus that is zero order, first order, and pseudo first order type of reactions. And we also have some numerical there, so we discuss later. So you have to complete this worksheet along with the date. Have a nice day.